Well, hello and good morning, everybody. Hey, here's what we're going to do. We're going to go over our homework from the polynomial functions section where we were talking about degree and possible number of x-intercepts. So I just dropped my pencil, but I'm ready to go. I got my brand new sharpened Dixon Ticonderoga number 2. I don't think that's going to focus. I got a pen. I got some scratch paper. Got the homework right off the printer, and of course, it is the morning of April 9th, 2020. So we're quarantined. It's Thursday. Got my Mr. Rogers t-shirt on. Thing I liked about the movie is kind of the takeaway is that, well, his message was that it's important to find positive outlets for the negative things and the dark things we experience. So that's something I'm not very good at, but I think it's a good endeavor and a good focus, especially in today's time. So, coffee time. It's not very good, but it's hot, so that's good. That's allergy season. So let's get to our stuff here, shall we? Here we go. All right. So we have to do two things here for this first part. We have to find the degree, and we have to find the x-intercepts. Now it's a good habit to make sure you read the directions carefully, always, right? So it says determine the degree and the possible number of x-intercepts for each of the following functions. So here's our function. Now the degree, it looks like it might be 2 when I just look at it, but if I think about what's going to happen over here, when I multiply these two things together, you're going to get an x squared, and that's going to be multiplied by another x, which gives you an x cubed, so the degree is 3. If the degree is 3, there's either 3, 2, 1, or 1 x-intercepts. It actually turns out that, and this is something you're going to learn in the near future, if the degree is odd, you're always going to have at least 1 x-intercept. And the reason why, and you're going to see this in the near future, if the degree is odd, it's going to look something like this. That's when a is positive. It could be the other way too. It could go down. I mean, you can have all these different kinds of turning points and stuff, but it's going to go up one direction and down the other, so it's always going to have at least 1 x-intercept if the degree is odd. Now, if you wrote 0 based on just what you know right now, that's perfectly okay, but in reality, it's like that. All right, now, let's talk about B, the degree for part B. Well, you see how we have this 3 here times that x? So that's x to the third times another x, so that's going to give you a degree of 4 right there. But this is being squared, and then you have to multiply all those together, and those are exponents, so it's going to be x to the 6th. So you're going to have 6, 5, 4, 3, 2, 1, or none. That's your possible number of x-intercepts for that one. Now, degree, number of x-intercepts. So for this one, this is going to be a degree of 2. We could have 2, 1, or 0 x-intercepts. This one is a degree of 3. It's just a little out of order, right? It's not the first thing you see. It's the largest exponent, what we're looking for. So the number of x-intercepts for this is going to be 3, 2, or 1. Yeah. Now if you wrote 0 once again for this, for like what you know so far, you're good to go. So here's what I want you to do. If you're watching this today, I would like you to make sure you send me an email, let me know, or send me a message on Google Classroom, whatever. Let me know how it's going. If you have questions, I'd really appreciate it if you just put them in the comment of the video, because those comments will be seen by people in the future, and other people's questions might be answered when I respond to them. All right, so let's get to the next part, shall we? All right, now let's see here. Find the y-intercept of each of the following. Now, the way you find a y-intercept is, if you remember, you put a 0 for the x. That's all you got to do. So if I put a 0 for x, I put a 0 for x, put a 0 for x, put a 0 for x, it's going to be a 0. And here's why. Here's why I know that right away. So if I put a 0 for x, that's a 0. No problem, right? But if I put a 0 here, it's going to be 0 times something else. 0 times anything is 0. So the y-intercept is like that. So y-intercept, the way you find it once again is you plug in a 0. Make sure you write your intercept as a coordinate, because you know how even with when you were graphing parabolas, you'd have x-intercepts, you'd have 2, but potentially you'd have a y-intercept, you have a vertex. if you just wrote numbers, like 0, you might get yourself confused. So you need to make sure you're writing coordinates, especially for these polynomial functions. You're going to have a lot more information to be graphing. So got to be careful with that. Next one. Hey, same thing. When we plug in a 0, this is going to be 7 times 0, which is 0 times who cares times who cares. I mean, this is going to be -3, and this is going to be a 1, but it doesn't even matter because it's times 0. So once again, we have a y-intercept of 0. So it goes to the origin, 0, 0. This one. So f of 0, right? So that's going to be 1 times 1. So that's 1. So we have 0, 1 is our y-intercept for this one right here. So all I did, put a 0 for x, put a 0 for x. So this is 0 plus 1, and 1 minus 0. So it's 1 times 1. There we go. This one right here, it's going to be 0, -20. Because once again, you put a 0 for x. These are all multiplying. So 5 times 0, 2 times 0, 8 times 0, they're just 0, so you're just left with -20. Boom, done. Once again, got a question? Leave it in the comment. I would really, really appreciate it, because this will help people in the future when they're learning this. And it might really help expedite some of the learning process. So, next up, number 3. Now, here's where it gets a little tricky. We have to find the x-intercepts of each of the following. Oh, man. Now, if you remember, when we're going to find x-intercepts, with what we know right now, there's something called the rational root theorem. We're going to do that in the future. But for what we know right now, what we have at our disposal for finding x-intercepts is we set the equation equal to 0. That's always the same because y equals 0 for any x-intercept. So what we can use, sometimes we can use inverse operations. Sometimes we can factor. And if it's quadratic, we have a formula at our disposal. There are other formulas for cubics and all those things, but those are so convoluted, so huge and confusing, we don't even want to get in there. So I have my calculator here. If you're working from home right now, you don't have a calculator with you, you might not know this, but on your phone, let me open up my phone, get my calculator here. Let me show you. A lot of the time when, look, here's my busted phone. When you look at your calculator, there we go. It's not a scientific calculator, so it doesn't do the complicated things you need, right? So all you got to do is turn your phone sideways. This works for both Apple phones and Android phones. So if you just turn your calculator on your phone sideways, you will have a scientific calculator. This is a graphing calculator, but you get the idea. So we're going to set them equal to 0. We're going to factor. We're going to use inverse operations when we can, maybe the quadratic formula if we have a part that's quadratic. But factor, set each factor equal to 0. So you make an equation for each factor equal to 0. The reason you do that is you're trying to figure out what value of x would make that factor equal to 0, because 0 times anything is 0. And then you solve them. So let's do it. Coffee time first. Man. Okay. So find the x-intercept for each of these. So we have to set it equal to 0, and we have to factor. So when I see this right here, this one's a little tricky. 3 plus. Let's see. I don't think we can solve this one. Let's find out. It's going to be a degree of 3. So let's go ahead and do this right here. Let's see if we can find these right here. X squared plus 2x minus 8 times 2x, right? And so that's going to give us 2x cubed plus 4x squared minus 8x plus 3x squared. So here's what we got. 2x cubed. And then 4 plus 7x squared. So you have 4x squared plus 3 more is 7x squared minus 8x. Okay. Now, normally I would not distribute here. Like on these others, I'm not going to distribute this, but I did here because you see that's a plus. Man, so that's frustrating. But what happens if we take we can factor an x out of this, right? So I'm going to go ahead and move over to some scratch paper now. So check this out. And just to be clear, because I did kind of do it as scratch work and I was running out of space, and I know myself, when I try to squeeze some work into a small area, like I did here, I often make a mistake because I'm trying to do too many little steps in my head, and it's easy to make an addition error. Okay, so this one stays the same, 3x squared plus 2x, and then let's multiply those together. X squared plus 2x minus 8. Okay, now when we distribute, we're going to get 3x squared plus 2x cubed plus 4x squared minus 16x. See, I did make a mistake. That's funny. I did not plan that. That is completely on accident. But I just know my own tendencies to make mistakes when I try to cram things in a smaller space like I just did. So, yeah. Okay, now, this is all equal to 0 because we're finding x-intercepts, right? So, we can combine like terms right here. So here's what we got. 2x cubed plus 7x squared minus 16x. Now let's go ahead and factor out an x. Okay, so we got x, and then we got 2x squared plus 7x minus 16. Now, let's see. I don't know if this is factorable or not. There's lots of different ways to factor something like this, right? So I'm just going to try real quickly to see if I can factor that. It's called guess and check, right? I know it's going to be 2x, and it's going to be x, and I know the signs are different. And so we could do 4 and 4, 2 and 8, or 1 and 16. So if I do a 4, no. 2 and 8, no. Yeah, I don't think this is factorable. So we're going to have to use the quadratic formula for that. Okay, so get it factored. Set each factor equal to 0. So this factor is equal to 0, and this factor is equal to 0. Here, we can use the quadratic formula. So I already have one answer. I know that it's going to go through the origin. I also knew that anyway, because check this out. Check this out. When I found the y-intercepts for this one, do you see how we found out that it goes through 0, 0? Well, 0, 0 is a y-intercept and it's an x-intercept. So I know it's going to go through 0, 0. All right. This one right here, let's do it. X equals -7 plus or minus the square root of 49. Let's see. Now, it's going to be 2 times 4 times 16. And it's going to be a -4 and a negative, so you know how it's like, you know how it's b squared minus 4ac. So here's what I know. It's -4 times a -16, so the whole thing's going to be positive. So that's 64 times 2 is 128 over 4, because it's over 2a. So let's go ahead and bust our calculator out right here, right? So here's what we got. I'm just going to go ahead and do this so I can write it down so I don't mess it up. 177. So let's do -7, -7. All right, let's see. So -7 plus the square root of 177, hit equals, and then hit divide by 4. Okay, so we got a positive 1.58. I'm going to round it to 3 significant figures. So there's one x-intercept. Now, if you notice, you see I did this first operation first and then hit divided by 4 after, because when you do the order of operations, that numerator is a group, and so it has to be calculated first, and after that's calculated, then you divide by 4. You could do it on a calculator like this. Let's see, square root 177. I needed to do this right here. I had to put the whole thing in a group. -7 plus the square root of 177, and then divide by 4. So to me, that's just so many parentheses. I mess it up, so I'd rather do it in 2 steps. All right, next one. -7 times or minus the square root of 177 equals, divided by 4 equals, and then -5.08. There we go. So we have 3 x-intercepts for this one right here. We have 0, 0. We had 1.58, comma 0, and -5.08, comma 0. So there are our 3 x-intercepts. Now, if I was doing this at home, let's say I didn't know how to use this, right? Let's say I was doing this at home and I wanted to check. There's a couple ways you could do it. You could check on Desmos. So, I mean, I'm using my computer right now, but even if I just had my phone app, Desmos is free. It's fantastic software. So let's use Desmos to check our answer. Let's graph this, shall we? So 3x squared. busted up my my phone right here, plus 2x parentheses, x minus 2, x minus 2, close parentheses, another group, x plus 4. Now the reason I'm doing this, instead of typing in, the reason I'm typing in the original, instead of typing in this, is because if I made a mistake changing from here to here, then I might not find it. Alright, so here's my graph. I got 3 x-intercepts, it looks like, right? Looks like one goes to the origin. That's excellent. 0, 0. Let's see. Positive 1.58. Yeah, see. And negative 5.08. So we are good to go. So that's a way that, if you're learning at home, like we are now, and you want to have, I don't know, just an extra check, yeah, be smart. Use your tools like that that you have at your disposal to help you out. Okay. So, once again, if you have questions on that, I would like you to please leave them in the comment, because it's going to help other people in the future. Also, if you leave in the comment, but you also want to make sure we talk about it later today, like if you're in my class today, we're going to get together in a, I don't know, in a Google Hangout or something like that, then we can go over it then too. But it would be really good if the question was there, because it would help everybody else out. So if you do that, it'd be great. Now, let's get to the last one. Let's get to the next group right here. So this one, check this out. Our first step is to factor. This is already factored. Look, you factor it. We have 1, 2, 3 factors. You set each factor equal to 0, and then you solve it. So 7x equals 0. Excuse me. When you solve that, you just divide by 7, right? And so you get 0, 0. You divide both sides by 7. X equals 0 over 7, which is equal to 0. Boom, done. Okay. X cubed minus 3 equals 0. Man. Let's do this one on some scratch paper right here. So let's go ahead and do the whole thing. Okay. So we'll set it equal to 0 because we're going to find the x-intercepts. So we take each factor and set each factor equal to 0. Okay. Now let's see. Like normally I wouldn't show the step, but like inverse operations, right? You have to get x by itself, so you divide. 0 divided by 7 is 0. So we have 0, 0. This one we have to use inverse operations, so we're going to do that. And then we're going to do x is equal to the cube root of 3. Do you see? Cube root. X is equal to the cube root of 3. Dang. How many answers are there to that? For square root, there's 2, right? So here's where this is kind of tricky, and you might not know this. So like the square root of 4. Let's do the square root of 4. The square root of 4. Let's do the square root of. Let's do 64. Here's why. I'll show you why in just a second. Because we're also going to do the cube root of 64. Okay, square root of 4. It's asking what squared is 4. Well, there's two numbers. 8 times 8 is 64. So 8's my answer. But also negative 8 times negative 8 is positive 64. So this has two answers, right? But what number times itself 3 times is 64? Well, 8 times 8. Sorry. 4 times 4 is 16 times 4 again is 64. Yeah? But check this out. The negatives don't work. Because a negative times a negative is positive. Right? So this is a positive 16 times a negative 4 makes a negative 64. There's only one answer. There's only one answer. So, yeah. So for this one, x equals the cube root of 3. So let's see. So you could say cube root of 3, comma 0 as your x-intercept, or if you wanted, you could do cube root on here. There's a couple ways you can do this. You could do, the way I would probably do this is I would say, you know how cube root is an exponent of 1/3? So I would probably say 3 to the power of, you need parentheses, 1/3, and 1.44, 0. All right. Now, next one. We're going to solve this. you don't need to, for this, you don't need to square it. You don't need to square it and then try to factor it and do all that kind of stuff. You just take the square root of both sides, right? Square root of 0 is 0, so x equals -1, so we have -1, 0. So we have 3 x-intercepts here. 1, 2, 3. This one's repeated. There's actually 2 of them there. There's 2 of them because, you know, it's really going to be x plus 1 squared is times x plus 1. And so if you were to write that out, it would be x plus 1 equals 0, x plus 1 equals 0. So this is a repeated root. You have 2 of those, right? But yeah, that's okay. So now let's go ahead and use our buddy Desmos again, just to check our stuff right here. All right. So let me get our phone ready. See, yep, we can see all that. So let's plug in our equation. So here's what we got. We got 7x, and then times. Let's see, x to the third minus 3, yep, and then close that parentheses, next group, x plus 1, close parentheses, squared, and let's see how we did right here. All right, so it's a funky looking graph. So this is kind of interesting right here. You see this x-intercept, it doesn't actually cross and go down, it kind of turns around right there. Do you see? And then so we have 0, 0, and 1.44. So we had 0, 0, 1.44, and 1. Good to go. So that's fantastic. All right. Next up. So we had, next up is this one. Now this one's a little simpler. This one you could do probably your freshman year of high school. So it's already factored, so we take each factor, set them equal to 0, right? The only thing you got to be careful of is the negative sign for this one. But this one right here, you know, you're going to subtract 1, and then you're going to divide by 4. So there's one x-intercept. You have -1/4, 0, or -0.25, 0. Either way you want to say it, same thing, right? This one, so we're gonna subtract 1. Right? And then when you divide by 4, you're actually going to get a +1/4. So there's our other x-intercept. It's going to be 1/4, 0. So we have 2 x-intercepts for this one right here. We have 1/4, 0, and we have -1/4, 0. Those are our 2 answers for that one. All right, now part D. I'm going to go ahead and do it right here. As I'm looking at this, do you see that for part D there are 4 terms? And it's out of order. So here's what I'm going to do. I'm going to put this in order. I'm going to do it like this right here. These were switched already. I switched them. So we're going to set it equal to 0. 2x cubed plus 5x squared minus 8x minus 20. Now when you have 4 terms, you have this thing called factor by grouping you probably forgot about. The thing about factor by grouping is what you want to do is you want to make 2 groups separated by a plus sign. And then you want to factor each of those groups. And all right, so we need a plus sign in the middle. This is a minus right here. So here's what we're going to do. We're going to make that a plus. Do you see? Same exact value as before. Factor each one. Try to set it equal to. Try to get those factors. So here we can take out an x squared, and we're left with 2x plus 5. When I factor this, I'm hoping I can get a 2x plus 5. If I take a -4 out, -4 divided out of 8x is -4 divided out of -x. -4 divided out of -x is 2x, and then -4 divided out of -20 is plus 5. So this is a number times a number. This is a binomial, but it's just one thing, and that's the same binomial. That's the common factor right there. So it's 2x plus 5 is being multiplied by x squared minus 4. Now this, if we were being told to factor completely, right, we wouldn't be done. I'm going to stop here to solve it because, look, what I have right now is I have 2 factors, and I can solve that. But x squared minus 4 is a difference of squares. It's x plus 2 times x minus 2. So if our objective was to factor completely, we can continue to factor this. that's factored completely. But because we're going to find x-intercepts, and this is a factor times another factor, I can solve this with inverse operations and a little easier. But if you did it this way, it's no problem either. So here we're going to get negative 5 over 2, because you're going to add 5, divide by 2, just like we just did on the last example. Here, you're going to add 4, and then you're going to take square root. Square roots have 2 answers. Do you see? So we have 3 x-intercepts. Our 3 x-intercepts are negative 5 over 2, comma 0, 2, 0, negative 2, 0. Those are our 3 x-intercepts. So there we go. Negative 5 over 2, comma 0, 2, 0, negative 2, 0. All right. 2 more to go. 2 more to go. Let's see. Let me see here. Man, 2 more to go. So this one right here, 9x squared minus 49, that's a difference of squares also. We could factor that if we wanted. And this one, x squared plus 4x minus 45, that's factorable. Negative 5 and positive 9. Yeah, that would work. So let's go ahead and do this one on scratch paper 2. 9x squared minus 49 equals 0, and x squared plus 4x minus 45 equals 0. So those are our two. Factors. So take each factor. So you set the equation equal to 0. You factor it, and you take each factor, set it equal to 0. So this one right here, we could do this 2 ways. We could factor this. We could say this is 3x minus 7 times 3x plus 7 equals 0. And so you could set each of those factors equal to 0, or you could use inverse operations. It doesn't really matter. Either way is fine. So since we already started this way, let's do it this method this time. Last time we did it the other way. On the last example, we didn't factor it completely, and we set it up like that. We used inverse operations, right? So here, you're going to subtract 7, well, you're going to add 7, and you're going to divide by 3. Here, you're going to subtract 7, and then you're going to divide by 3. So your 2 x-intercepts, 7 thirds, comma 0, negative 7 thirds, comma 0. Those are your 2 x-intercepts right there for this part. Okay? Now, if you were going to use inverse operations, like you would add 49 and then you divide by 9 and get x squared equals that, when you take the square root, that's plus or minus 7, that's plus or minus 3. See? Same thing. All right, now, this one is factorable, so because it is factorable, and you cannot use inverse operations to solve this because you have an x squared and an x, so you're going to have to either factor or use the quadratic formula. Probably better to use probably better to factor. So here's your 2 answers: negative 9 and positive 5. Because you take each factor, set it equals 0, boom, done. So negative 9, 0, 5, 0. There are our intercepts. Okay, all down except for one. We got one left. Let's talk about this hotness right here. And for this hotness, we have 3 things being multiplied. And so we're going to set it equal to 0. And we're going to take each factor, set each factor equal to 0. So let's go ahead and just start with that step. So 6x squared plus 11x minus 35. Ooh, it's probably factorable. And then 5x minus 4 equals 0. And then 2/3 x plus 6 equals 0. All right. It doesn't matter if the 0 is on the left or right. It doesn't matter. It's the same thing, right? So let's see if this one's factorable. Let's start with this one. Actually, hold on. Let's not start with this one. Let's say that we were going to do this like we were taking a test. If we were taking a test, I would suggest you do the easiest things first. So when you solve this one, you're going to add 4 to both sides, and you're going to get 5x equals 4, right? So then x equals 4/5. So one of your answers is 4/5, comma 0. Boom, done. This one, 2/3 x equals negative 6, because you're going to subtract 6 from both sides. That makes 0, which is what you want. You don't have to write plus 0. Multiply by the reciprocal. You see? And then just reduce. Negative 9. This 3 goes into 6. Sorry, 2 goes into 6 3 times. Negative 3 times 3 is negative 9. So negative 9, 0. All right. This one. Man. Guess and check. I know the signs are different. I need an 11 in the middle. Check it out. You know how this is a 7 times 5? It could be 7 times 5. Well, the difference of 21 and 10 is 11. Do you see? When I do the outside, I get 10. I do the inside, I get 21. And I need a plus 11x. So if I need a plus 11x, that 10 needs to be negative and the 21 needs to be positive. There's my two factors. 2x plus 7 equals 0. 3x minus 5 equals 0. So x equals negative 7 over 2. And x equals 5 over 3. So here are all of our intercepts for this one. And if we were going to do the y-intercept for this one, well, check this out. Let's go ahead and talk about the y-intercept, even though it didn't ask you to. If we were going to do the y-intercept for this one, you put a 0 for all the x's, you're going to be left with negative 35 times negative 4 times 6. So it's going to be a positive answer overall, do you see? Because a negative times a negative is positive. So whatever 35 times 24 is our answer. So 2, 12, 14, 0, 0, 7. So 840. Yeah, that would be our y-intercept. That's all of it. That's the whole kit and caboodle there, ladies and gentlemen. So let me know how you did. Let me know what questions you have, because as you know, learning math's not really about getting worksheets done. It's about learning. When you're doing those problems, it should uncover some misconceptions. That's like the biggest hurdle, is to uncover the misconception. And then after that, the biggest responsibility is to fix that misconception. Whatever it is that you got confused by, we got to fix. So when you're confused, all you've done is discovered that something you believed to be true is not true. Or if you're confused, then what you found is that there's something you don't even understand. And so you need to, either way, if there's something you've discovered that isn't true, and you discover that because you got confused, or if you've discovered that there's something you don't understand that you need to, you're going to get confused. So confusion uncovers those two things for you, and that's really fantastic. You just gotta fix it, right? So I'm here to help you fix those remotely. So you just gotta send me an email. Please leave me the comment leave me your questions in the comments, because I really want to use this to help people over time, not just today. And I think if we have some questions being answered like that, asked and answered in the comments, I think it would really help people out. So anyway, I hope you guys have a wonderful day. I hope to be able to see you guys soon, like face-to-face in person, so that way you can see how beautiful I'm looking right now. Man, need a haircut. Anyway, talk to you guys soon.